Hello everyone. I'm a third year medical student, and like every other student grilling with the Harrisons, I've been trying to find some video lecture series for my E's to study Harrisons, but unfortunately, I couldn't find any. So I thought maybe it will be easier if someone would explain everything in details from the various internal medicine books like Harrison, Davidson, etc. It would be really very helpful for all kinds of medical students throughout the world. So I thought of like you know trying to help others as well as myself regarding this issue. So I'll try my level best to make a few chapters easier. Let's get on with it. So I'll start with cardinal manifestation and presentation of diseases. And what do we mean by cardinal manifestations? It's like what happens when a person gets diseased. How do we understand that a person is sick? It's by the various manifestations which we call as cardinal manifestations. One of the most important cardinal manifestations being pain. Now, pain is a mechanism. Pain, we don't like pain, first of all. No one likes pain. But is pain really our enemy? No, I don't think pain is our enemy, because pain functions to protect our body. If we have pain, that means we get to know that we are ill. Okay, we have pain in the stomach, in the epigastric region, for example. That means we know that something is wrong with our stomach. So if you have pain in the left edge of the sternum, that means we get to know, we think of some problem with our heart. So pain is very important in localizing the place of injury, the place which is affected, the place which is diseased. And injury, as we all understand, doesn't really mean always cut or trauma. It can be a hypoxic injury as well, like an ischemic heart disease. So pain gives us a lot of pain. Actually, it's very bad to suffer from, but it's worse. The feeling is really bad, as we all know. At the same time, it helps in localizing the various pathological regions of our body. Now, pain is not always coming on its own. Like, pain is always followed by an emotional part. Pain always has an emotional part along with it, because with pain we have, for example, a person suffering from pain since a long time will not be in a good mood, will definitely not be like happy and in a jovial mood to go out for shopping, hanging out with friends. Definitely not. So somehow it affects our mood. That means somehow emotionally we are disturbed by pain. Now let me get into the medical part of it. Like, whenever we have pain, we have that sensation and that emotion together. So our blood pressure rises, our heart rate rises, our pupil dilates, our cortisol levels. Cortisol, as we all know, are the hormones which are always high when we are stressed. And pain is nothing but a stress. Actually, pain is the sensation, but the stress is due to the emotional disturbances, and the stress is due to the underlying cause of the pain. That causes the pathology of the body. The cause is the etiology of the pain. I mean, cause is the etiology. Definitely cause is etiology, but the etiology of the pain is the real culprit, not the pain. So how do we sense pain? For example, let me give you a very simple example. I got a cut in my hand, and definitely we have pain after a cut. So there are various fibers in our body. There are short diameter fibers, there are long diameter, broad diameter fibers, larger diameter fibers, pardon me. And the larger diameter fibers are termed as A beta fibers. They are really not involved in pain sensation. So since we are concentrating more on pain today, we would not go to speak about A beta fibers, but rather we would concentrate on small diameter fibers. What are small diameter fibers? Small diameter fibers are nothing but the C fibers, which are unmyelinated, and the A delta fibers. Mind you, I forgot to say, A beta fibers are also myelinated. These A delta and C fibers are responsible for pain sensations. So since they are responsible for pain sensations, and pain is coming from stimulus, noxious stimulus, we call these receptors or afferent fibers as nociceptors. Now, from these nociceptors, from the primary afferent nociceptors, the pain sensation travels to the spinal cord. And we all know that all kinds of sensations come to the dorsal root of the spinal cord. So I think I'll show you a diagram, it will be better. Okay, so let me just, okay, I've got a good diagram for you. So there is the injury, and after the injury, the nociceptors are affected. They are firing, and they finally reach the dorsal root of the spinal cord. And after reaching the dorsal root of the spinal cord, they contact with the spinal nerve. You see the little dot over there? That's the beginning of the spinal nerve. And the spinal nerve actually crosses over to the anterolateral region of the spinal cord of this segment. I've shown you a transverse segment of it, and then it ascends to reach the contralateral side of the thalamus. Why contralateral? Because it's clearly, you can see it's crossing over. So naturally, if it would have been the same side as that of the injury, it would have been an ipsilateral side. But since it is crossing over to the other side, we call it a contralateral side, signaling to the thalamus. It goes to the thalamus, and thalamus sends these signals to various regions of our brain. Two of the most important being the somatosensory and the frontal. And the somatosensory basically deals with the quality of the pain, that how painful it is, the sensation type, the quality, everything which can be like how to say, it can be qualitized basically. And it sends to other regions like the frontal region, the emotional, the limbic system it affects. So ultimately the other regions that are affected are mostly responsible for the emotional part of it, the emotional part of the pain. Now after reaching the thalamus, it sends signals that are descending down. It sends signals that are descending down. The hypothalamus sends signals that descends down to control the pain sensation, to control the entire ascending system. The hypothalamus is the one deciding whether there will be pain or not. If the hypothalamus wants, it can induce pain. If the hypothalamus wants, it can also reduce pain. And throughout this circuit, there are receptors, various receptors known as mu receptors. Mu receptors are receptors that are there for, like you all know about the analgesics like opioid. So they are opioid receptors. Opioids, to reduce pain, act on the mu receptors. But opioids are not only taken intravenously or orally or exogenously, frankly speaking. To be speaking about a broad thing, exogenously opioids are not only taken as exogenously as we all think about it, but opioids are also there present in the main neurons controlling the main neurons the main nuclei controlling the circuits. The main nuclei controlling the circuits have endogenous opioids known as enkephalins, endorphins, and they are also released. We'll get to it soon. So this is the concept of the entire circuit. Now, what is sensitization? Let me get to sensitization. When a person gets injured, or when we keep on continuously after a fixed interval of time keep on poking the same region, or the same affected region, that means we are poking the afferent system, the primary afferent nociceptors continuously in fixed intervals of time, regularly actually. So due to this, they become their threshold. The threshold, as we all know, that we need to reach a threshold so that an action potential can go on through a nerve. So if we do this continuously, our threshold decreases. Our threshold decreases to an extent that even with a small touch in that region would make the person shout in pain, would put the person in an extremely agonized state. So what is responsible for it? There are various other substances which are released during such kind of injuries, like bradykinin, leukotrienes, prostaglandins, as we medical students must be knowing about all these things very well. So these are ultimately responsible for lowering the threshold for the nociceptors. Now, this particular thing is known as, this particular phenomenon of lowering the threshold to an extent that even with a touch of a person, the injured one shouts with pain, is known as sensitization. It can be for the peripheral nerves, it can also be in the central, that is concerning the CNS. So it can be central sensitization as well as peripheral sensitization. Now, let me talk about silent nociceptors. Like, there are nociceptors which remain dormant. Like, we have heard about the dormant volcanoes which only erupt suddenly out of nowhere. Silent nociceptors are somewhat like that. When we mechanically irritate that region, some region where there are silent nociceptors, there will be no pain sensation. But if that region is having some kind of inflammation, and then we mechanically irritate that region, there will be pain sensation by those conducted by those silent nociceptors. So since they are reacting only sometimes, not always, we name them as silent, not dead. And let me speak about nociceptor induced inflammation. Now, what is nociceptor induced inflammation? Nociceptor induced inflammation is like these afferent nociceptors, these afferent fibers of these nociceptors. There is definitely a cell body for it, and the cell body has nissl substances in it. Now, these nissl substances are nothing but they are vacuole-like things which has some kind of proteins being made continuously. It depends, it varies from cell to cell. For these kind of nociceptors, the 11 amino peptide type protein is substance P. Now, substance P has got few functions. It is a chemoattractant. As we all know what is a chemoattractant. Okay, fine. It attracts for a more simple explanation. It's like all the inflammatory mediators are suddenly induced by this substance P. So why sometimes due to pain we see a person's for example, a person is agonized very, very much. Suddenly we start seeing that the region where the pain is, it starts swelling. there's inflammation. So where does this inflammation comes from? It can be any pain. It is not necessarily that there has to be any kind of inflammation, infection to get any kind of inflammation. In this case, is the substance P that is responsible for it. The substance P helps in chemoattraction, attracting the various cells towards the site of the pain. It helps in increasing all kinds of inflammatory mediators. So that is all about nociceptor induced inflammation. Okay, now I want to talk about the spinal cord and the referred pain. So what is a referred pain? You guys would have heard about, definitely should have heard about referred pains, like very common example being heart attack, and the pain being somewhere in the left shoulder region or the left jaw region. Why is it so? It is due to the simple fact that these afferent fibers, I mean, there is one receptor, the pain sensation is going, and then it is activating 4 different spinal cord segments. It is a divergent one. Okay, so the sensation is coming and it is activating the same pain sensation from here, is activating 4 different spinal cord segments. And each spinal cord segment, that is a divergent one, remember, and each spinal cord segment is receiving thousands of different afferents, primary afferent nociceptor fibers. So it's a convergent one. So everything is coming towards me. So when everything is coming towards me, sometimes I get confused that whether it is coming from there or is it coming from there. So in that kind of confusion, believe me, we get the referred pain. So how do we explain it in case of heart attack? The pain sensation is coming from the heart, and the same segment of spinal cord is also the skin of the left shoulder and the jaw region is also going to the same segment of the spinal cord. So the spinal cord just gets the pain. It gets confused between the place from where the pain is coming from. That is why we get the referred pain. Okay. Now, pain modulation. As I already told that pain modulation, for example, a soldier who is on a war, he's fighting, he's getting several injury, but he's still fighting for his country. As we all know what a soldier actually does for his or her, his respective country. So